Okay, good morning, everyone. We're going over Lab 11 today, spatial analysis and energy sources. So last week we were talking about, we went over greenhouse gases and CO2, methane, things like that, but different energy sources, depending on whether they're renewable, non-renewable, they also give out varying amounts of CO2 or greenhouse gases. So say for renewable, we have hydro, solar, wind energy. For non-renewable, we have our fossil fuels and coal energy, and they all give out during the pre-production process or actual processing, implementing different amounts of CO2 or greenhouse gases are emitted. So to compare them, we're going to want to look at their metrics or the units, and just keep in mind that even though units may vary, this is what one means to each other. So our typical unit is 1 kilowatt hour, which is 1,000 watts used for 1 hour. This is our standard unit of electricity consumption. So if you look at your electricity bill, this is what electric companies, they bill you using kilowatt hours. So if you ask like your parents or your aunts and uncles to look at their electricity bill, this is what we'll see. 1 British thermal unit, 1 BTU, is the energy required to heat 1 pound of water by 1 degree Fahrenheit. So 1 pound of water is 16 ounces. That's a little bit more than like a plastic bottle of water. So 1 BTU is the energy to heat up a little bit more than that amount of water. 1 standard barrel BBL of oil is 42 gallons or 160 liters, and it's also equal to 5.8 million BTUs. And 1 metric ton of standard coal is equal to 27.8 million BTUs or 4.8 BBL of oil. So if we're looking at two different types of energy sources, so coal versus natural gas, they both emit different amount of CO2 through the process of implementing and sourcing them and using it. So coal, we have the CO2 emissions from producing coal is 1,350.5 million metric tons MMT of CO2. Well, compared to natural gas, it's a little bit less than half of that. But people usually think that natural gas, there isn't any CO2 emissions from them, from producing natural gas. That's actually not really true. That's maybe around, yeah, a little bit less than half, smaller in scale compared to coal. But during the production process, before we actually have natural gas to use, we need to use like machines and all of these other processes that need to be, that need energy too, and that energy could be from coal and fossil fuel. So that's why there is still a CO2 emissions from natural gas, but it's a lot less. One nice thing about thinking about coal, even though it's like it's polluting, it's like it emits a lot of CO2, it's that coal is a finite resource. There isn't an infinite amount of coal out there. Once you're done mining for it, unless you wait 1,000 years or more, there's really not going to be any more coal for coal companies to keep digging up for. So coal companies, they know that too. So there's a bigger shift to renewable energy just in the market, where coal is increasingly getting more expensive, and renewable energies, because of government subsidies and things like that, are becoming cheaper to produce. So there's a shift in the market to using more renewable energy. And we can see that too with, if you live in California, we use our electricity from PG&E, Pacific Gas and Electricity, and they, most of it, that if you do get your energy source from them, it is from fossil fuel and coal, but there's a bigger shift to using more renewable energy, mostly solar, bigger shift to wind, because wind is very easy to implement and maintain. So thinking about the jobs created, because this is one aspect people do pick on when they're saying, oh, well, renewable energy, what about like the jobs that they're taking away from non-renewable energy fields? Well, if we're thinking about this in terms, this chart is from 2016, where we're looking at the amount of jobs created per gigawatt hour of energy generated. So for 1 gigawatt energy generated using solar, around 6.5 jobs are created, where compared to coal, like not even one. job is created per gigawatt hour of energy. And these are high quality jobs too. So high quality as in highly skilled people can um, take these jobs. And I think that's also the caveat of that. Yes, there's like more jobs created, but these jobs are for people with more education and who are more highly like qualified and highly skilled. So that's the other caveat of that. But that's why we can see it in the energy salaries. If we're looking specifically at solar, the range for solar, for jobs in the solar field is wider though. So that can be, it's like around 50 to a little bit over 100K annually. And this is always, and these fields, electric, for solar, for renewable energy and things like that, it's growing too because we need more jobs in these fields, like people to mine for solar materials, people who work in policy, people to install and stuff like that. So this field is growing, and the jobs within this field are also like growing too. And now if we're looking at the cost of production between the different sources, we have our greenhouse gas, or not greenhouse gas, our natural gas in purple here. And so for the amount of money it takes to produce 1 megawatt hour is around 60 to maybe $90 for megawatt hour for gas. For coal, it's around 60 to $120. And the cost of production is higher for coal. And we know that because coal, you have to continuously mine for it. You like to produce the same amount of energy, we still need to put in a lot of money to pay people, to pay these equipment, and pay these like companies to keep on mining coal out for us to use. But compared to coal, if we're looking at solar PV, the cost of production is a lot lower. And generally we know that because once we mine for the materials to make solar panels, we don't really have to worry about them after we install them. There are maintenance fees, and there are little things to keep, like for upkeep for these solar PVs, but usually you install them and you don't really have to worry about them afterwards. You just leave them up and they produce energy on their own. So the cost of production would really just be for the initial mining process, implementing and installing. But that's why we can see that the cost of it is a lot lower. For Europe and the US, it's pretty equal to each other. The cost of production for China is a lot lower, and for India, it's a lot lower too. And one thing to note about India is that as they're becoming, as they're striving for this economic middle class, there's a lot of potential for them to like introduce and implement like efficient energy standards, because right now a little bit more than half, maybe 70% of the infrastructure that they're planning to have built by 2030 hasn't been built yet. So there's a lot of potential for India to set up efficient, like aggressive energy efficient standards. And this is going to take a lot of working together, like collaboration between the energy companies and the energy industry and policymakers, and also a lot of aggressive like solar PV installation. But I think it's a lot of potential like going forward, especially as they're still developing too. So now if we're looking at global energy capacity by source, there is what is like the shift between different energy types over time. This chart looks at 2010 to like a 2025. By 2024 it stops here, but comparing, say we have our hydro in this dark blue line. So there is an increase in demand for hydropower over time, but it's not super dramatic. And that's because once you put in your dam, once you put in your water turbine, you don't really do anything else with that unless you just find other waterways to put in more dams, to put in more water turbines. You can't really do much else with hydro. So it is increasing over time, but it's not super dramatic. In the light blue for gas, again, we see that we have it's like a little, our dependence on it is a little bit higher, but also super steady line, not super dramatic increase in its use. And we know for coal that right now this is the energy source that we're most reliant on. But eventually, like right now, we can see that there is like a decrease in our use, our dependence on it. And that is because, like I said before, there is a shift in the market where they know that coal is a finite resource. Once you're done mining for it, it's basically gone. So there is like a shift to other energy sources from here. So there is a decrease that we are starting to see now, and it will probably continue into the future. And we also have in this purple at the bottom, this is nuclear. It does exist, and it's pretty steady. There's no increase in it over time. And this graph actually shows the start of 2010, but this line, there's no increase in nuclear because in 2011, there was the Fukushima nuclear power plant disaster where a lot of radioactive waste and all of this nuclear waste was leaked out from this power plant, and around tens of thousands of people had to evacuate because it went into the air, the soil, groundwater, and things like that. So this, after that event, it scared everyone like around the world. So no more nuclear plants were built afterwards. I know there's plans, talks of maybe opening up more nuclear plants, but it's nothing really substantial, nothing really like set. But afterwards, a lot of people were scared off of it. But before that disaster, they said that nuclear was the power of the future. It was, they considered it really clean, and the amount of energy produced from nuclear, it produced a lot of energy. So that, but afterwards there's not a lot, but these nuclear plants are still being used, even though they haven't been building anymore. That's why this line is pretty steady over time. It's just not going to increase anytime soon. And in red, in this thick red line, this is wind and solar. And this is increasing over time too. So we're seeing now that there's, it's getting cheaper because of government subsidies to help companies build wind turbines, solar PV farms, and things like that. And they also have a complementing relationship where during the day when there's a lot of sun, that's when your solar output is really high, but your wind is usually lower during the day. And then as you transition to night, the amount of solar you're going to get is going to decrease, but then wind starts to pick up. So there's like this balance where during the day you'll have solar, and that's where you can get your energy, most of your energy from, and wind more at night. And so they're complementing in that sort of way. And we're seeing that's also predicted to increase our reliance on it. It's going to increase over time too. Now, if we're thinking more about how we get coal, one of the ways that we source coal is through mountaintop removal, where you have your mountain, they blow off the tops of the mountain, and then they dig out the coal from underneath. The whole purpose of mountaintop removal is to take the coal miner out of coal mining, but it also has a lot of effects on implications on the areas surrounding mountaintop removal, like all the debris and all these particles that once they blow it off, it has to go somewhere. So you move it, if they're moved into areas that didn't have all these particles before, all these like debris, it could change like the flow of water. And so places that didn't have water now have water, and now they're flooding areas. And you also have to think about the byproducts of mountaintop removal or coal mining in general, and where you dispose of that also has like implications on the surrounding area. But this video is going to go into more detail on that. It's a little dated, but it is it's pretty descriptive, and it describes like mountaintop removal in the US. Let me make sure that that I'm sharing my computer sound. Okay.
Environmental rate, that's all you can call it. It's the environmental rate, that's all you can call it. They've just destroyed our way of life completely. Everything that the mountains meant to us has been destroyed. Since this land got disturbed by the coal and timber companies, we don't have hardly anything left.
Just southwest of our nation's capital, one of the greatest human rights and environmental tragedies in American history is taking place at this very moment. Mountaintop removal is a form of coal mining that's designed from the start to take the coal miner out of coal mining. The companies use explosives to blow up the tops of the mountains, and they dump the rock into the valleys, totally burying the streams. What's left behind is a moonscape.
When you're blowing up, literally blowing off the top of a mountain in order to get at the coal, and all of the debris and everything else, the whole top of the mountain goes down in the valley, dams up rivers, affects communities. I mean, it's just wrong. It's just wrong. It's so deeply wrong that we have to do something about it.
When they level the mountains, they have to have something to do with everything other than the coal. The leftover debris is put into the headwaters of the hollow. And it changed the velocity and the volume of water that comes through my property here. And we've always had a small stream run through here. It's named Big Branch Creek. It's always been a little tiny stream though. And through the manipulations of the headwaters of the stream, I've been flooded now 7 times. In 2001, the bridge washed out and we repaired it, and then it washed out again. So I lost 2 bridges. And at this point, we have no access.
My son called and he said, "Dad," he said, "if you're getting home, you better come on." He said, "It's starting to flood up here." So we got down to the mouth of the hollow, and this 15-year-old boy met us, and he said, "You can't get up a holler." He said, "It's flooded." In a matter of an hour, this 15-year-old boy was drowned. And with him, his neighbor, a 35-year-old lady, they stepped across a little ditch going into their yard that normally was 6 or 8 inches deep, and they were swept away. We spent the night together, all of us huddled around in this house, and it was a night of unbelievable sorrow.
This isn't just a regional issue, because people from all across America use electricity that's at least partly generated by mountaintop removal coal. But it's a small amount that could easily come from cleaner sources of energy.
Instead of going under the mountain and getting the coal, they just take the mountain off of the coal, and they scoop out all that coal in that seam, and they go on down to the next seam and push all the overburden over the mountains into the valleys, and they get that seam. And as I said, there's 8 or 9 seams here they got, and each time it's more dirt and rock come down over the valleys. They say it's more economical. They take a handful of men with equipment and accomplish in a matter of months what an underground mine would take years with a lot of men to do.
It's providing cheaper energy for our society, cheaper costs, big profits for coal companies, a few people are getting jobs, but it's a one-shot deal. And those mountains and those streams are not going to really recover. And it's breaking covenant with God and creation.
The streams that go by me here right now are the headwaters of the streams all over the eastern United States. And whether people realize it or not, everyone's downstream from this. The planet shares water, you know, and if there's one drop of it polluted, then all of it's polluted.
All of this is happening in a region that's a national treasure, home to bluegrass music and the Blue Ridge Mountains, and it's also home to more species of plants and animals than almost anywhere else on Earth outside of the tropical rainforest.
the worst thing that has ever happened to this state. And it's not even being discussed in the political debates. I'm here to mourn the stupidity and the ignorance that says coal is West Virginia. West Virginia is mountains. West Virginia is not coal.
Coal fields, as they're called sometimes, the southern Appalachians, some of the poorer areas in the country, and yet some of the greatest wealth has been extracted. There's something wrong.
To know that me and my children have been sacrificed for the wealth and riches of other people is very frustrating. But at the same time, I have to direct my anger and do something about it so that my children have a possibility of a future.
It's a national sacrifice, and as I see it, in a sense, a cultural and economic theft, at least a con that they're trying to perpetuate.
It has to change, and it will change on an individual basis. Everybody has to stand up and fight it.
Everybody coming together and voicing their concern together, actually a communal effort really is what it is. Through Appalachian voices can make a difference and will make a difference in this fight. But it's definitely going to take a concerted effort.
Growing up in East Tennessee, I thought the mountains would be there forever. But in my lifetime, more than 450 mountains have already been destroyed. And if we don't act, hundreds more mountains will be lost forever. To stop this, we have to remove the cloak of secrecy that's allowed it to go on. And that's why we created ilovemountains.org. Thanks to new technologies like Google Earth, the coal companies can no longer hide the massive scale of destruction that they're causing. Together, we can meet America's energy needs and protect our nation's natural and cultural heritage. But it won't happen without you. Please help us spread the word. And thank you.
How many years can a mountain exist before it's washed to the sea?
So all of these flags are the different mountains that have been taken out from mountaintop removal. And yeah, a lot of side effects from mountaintop removal that we see in the surrounding communities. And we're going to be using Google Earth Pro, like they mentioned in the video, to actually look at some mountaintop removal sites and look at the sludge dams where that's holding in the toxic sludge and things like that. But yeah, mountaintop removal, one of the ways that we get coal. So, but now if we're moving on, one of the other ways that we get our energy from is through wind power. So the, I guess first off, we can talk about the old design of wind power, where wind turbines, they used to have scaffolding. It used to be really small, where they just had scaffolding and then this lattice-like structure in between. They also had short blades that moved really fast. So one of the things that people protested in the beginning was that they caused a lot of bird deaths. And that was because of the scaffolding and this, all these little places, nooks and crannies that birds can hang out on. They like to roost there. They like to just hang around these like old wind turbines. And that's why, and because the blades moved really fast, it caused a lot of bird deaths. So that was with the old design. Now the new design of wind turbines, they're a lot bigger now. They have like a pole structure and their blades are a lot bigger and they move a lot slower too. So bird deaths have gone down by a lot. And the technology is changing too, where wind turbines now last a lot longer. We have both onshore and offshore wind turbine. We also have floating wind turbines where it's not really tied to a place anymore and they still collect energy. And one nice thing about wind energy too is that, like solar, once you mine for the materials, you don't have to really worry about them. You just kind of leave them out to collect wind energy, and there are government subsidies to help pay for your wind turbines, to help these wind farms pay for the materials for it. But after a while, when you just leave them out there and to collect energy, they start to pay for themselves pretty quickly because you don't really need to do a lot of maintenance or anything for your wind turbines. So that's one nice thing about this is that the technology is continuously changing and it's getting better and better over time. So on this map, we can see the US. So in the middle where it's this big purple section with a little bit of blues and reds, this is where the wind speeds are at the highest. And this is the area that can harness the most wind energy. So this is one nice thing about that is, yeah, technology is getting better, a lot of area for us to put in wind energy, but even offshore or like on what like floating wind turbines can be along the coast too. Right, so again, the problem with wind power, one of it was bird deaths, where wind turbines with the old design kills around 1 to 2 million birds annually. But that was with, like, again, the old design. As like they're changing now, there's not that lattice-like structure. There's like, and the blades the fans are moving a lot slower. Bird deaths have gone down. But if we look at other reasons why birds die, feral cats, around a little bit over 500 million birds die because of cats. And then from just like birds flying into windows, around 100 million to like high 900 million birds die from windows too. So wind turbines do kill birds, and that was with the old design. It's getting down as they work on the design of wind turbines, but there are also other reasons why birds die. And and another issue people had with wind power was that they thought that it's just the aesthetic, it doesn't look good. And if you put it in people's, like outside of people's property or in the area, it would have an effect. It would just make their property values go down. So that was another reason why. And I am going to pause this recording because this is whatchamacall, it's copyrighted. So I'm going to pause the recording, but then show the video to show you that aspect on the aesthetic part of the aesthetic problem with wind turbines. Okay, so right.
Thank you very much. The Wall Street Journal. For years, you've known it as the paper wedged next to your rich uncle's toilet. It's the paper.
Okay, let me try that again. Right, so that was Cape Wind. So what happened with that is that a couple of years later, the lawsuits won. Cape Wind, the project didn't go through. And then, the wind turbines just weren't built on there anymore. Or like the projects for it just stopped afterwards. But more and more wind power is like starting. All these projects are coming up though, and plans to put up wind power is starting to go through. But specifically for that project, it didn't. So now, let me make sure you can see. Okay, awesome. Yeah. Let me just make sure you can see this. So another source of energy is through solar. And on this map of the US, we can see that in the darker orange here in, say, Lower California and Arizona and Nevada, these states, these are places that like we can put in a lot of solar PV, solar panels on, because they can collect like a lot of solar energy, a lot of sun. If we think about this, well, also the amount of solar that we collect throughout the day, it's more than we can use throughout the day. And because of because of the batteries that we have now, they can't really hold a lot of energy to be used for in the future. So, but these batteries to hold like these power, the technology for it is getting better. But if we had, say, a better grid, these states, we can trade like during the day, this solar, trade or sell this energy to other states. Say in that other map where in the middle of the US, these states here, they're the ones that can harness the most wind energy. So it could again be like a complementing relationship where if the electric grid was better, then and it is getting better over time, then like during the day when there's a lot of solar, more energy that we could, more electricity that we could use during the day, we could trade it to these other states, and at the night when they collect wind power, they can also trade it right back. But this is just a general map of the US to see where we could put the most and get the most of our solar PV. And that is basically it for my PowerPoint. If we go back to our Canvas page, say under Lab 11, we can now get started on our Google Earth Pro version part of our lab. So at the top, we have our Lab 11 background info, pre-lab quiz, and then you should have Google Earth Pro downloaded onto your computer now. And also make sure you click and download this Google Earth KMZ file for this lab. This is what we're going to be looking at. It's going to show like the study areas and specific coordinates for the sites that we want to look at today. So you'll just click download. Make sure you download it somewhere that you can find it, either in your downloads folder or wherever. Just remember where you saved it to, because we're going to open it up again in Google Earth Pro. The final lab assignment, the Word doc that you're going to be submitting, you can find it here, and you're going to submit it here. So if you just click open that, we have the doc. It gives us mountaintop removal, some background information on that, some background information on how to use Google Earth Pro, and where is mountaintop removal happening. In this map, it shows us within the black polygon lines that it's mostly in Kentucky, a little bit in West Virginia, and some parts of Tennessee. And that's where this is going to be shown. That this is like where we're looking at for mountaintop removal. If we keep on scrolling down, our very first coordinate that or the very first study site we're looking at is Mud River in Google Earth Pro. So the coordinates for that is 38.07 minus 81.98. But first, after you download Google Earth Pro, we're just going to open that, and it's going to look like this gray icon here. Once it loads and opens, it'll look like this. And it'll show us the general continental US. From here, after you downloaded that KMZ file, on your laptop, you can select File at the top of your toolbar, at the top of your screen, and click Open. And this is when we're going to open that KMZ file that you just saved. So you'll click Open on this drop-down menu, and a window like this should pop up where wherever you downloaded your KMZ file, if it's in your downloads folder or wherever you saved it, you're just going to click on that file and then select Open. Right. So on the general Google Earth Pro, this app, at the top left, we have our search bar where we can either put in the coordinates of where we're looking at or the place name. Right underneath it, we have places. And when you open your KMZ file, your places should pop up and show the Appalachian Mountains and all of these extra tabs. At the bottom, we have our layers window, and more layers might be selected on your Google Earth Pro. You can unselect, just keep borders and places, borders and labels, places, and terrain selected, and you can unselect the rest of them. Just because the more layers you have selected, the slower your the Google Earth Pro would load every time you go to a new site. So you can just keep these 3 selected. But if we go back to our Word doc, our first coordinate for Mud River is 38 -0.07, -81.98. So we'll just copy those coordinates, and we can go back into Google Earth Pro. And in our search bar in the top left, we can just paste those coordinates in and click search.
Hey, Maggie.
Yes.
On the downloaded files, I don't seem to have as many of the places as you have on yours there. Is that normal?
I think that's probably not a problem because I've also been working with Google Earth Pro for a while now. So
Yeah, I just have the Appalachian Mountains. That's the only one we're supposed to have, right?
yeah, just
Okay.
Appalachian Mountains is fine. Yeah.
Okay.
Okay. Awesome. So once you copy and paste and put in the coordinates into your search bar and it takes you to the site, it's zooming us in really close right now, but we can just use these tools on the side here to either zoom in, zoom out. We have our little person to, we can click and drag them to look at street view, and we have our two compasses to move around on our map. But we can zoom out now to look at our overall study area, which is in this yellow box. So this is Mud River. This is one of the coal mining sites that we're looking at to see how much land is affected by coal mining. And we can find the area of this land by making a polygon. So we can do that by, at the top of your toolbar, there's a bunch of different options that you can see. One of them is this add place mark. Right next to it is an add polygon tool. You can select that and a new window is going to pop up. And right now it says Untitled Polygon, but we can just rename it to say Polygon underscore Mud River. You're not turning in this KMZ file, you're only turning in the Word doc. So whatever you do in Google Earth Pro, it's really just for you to remember and refer to. So you can save it and rename it whatever you want, but you're not turning in this Google Earth KMZ file. But yeah, so you can name it whatever you want. So
sorry, Maggie, my Google Earth didn't come up with the Appalachian Mountains as a place. Is that okay?
Did you download the Google Earth KMZ file and open it?
Yes, I think so. I
Okay.
downloaded the Google Earth Pro yesterday.
Okay.
And then, oh, maybe I did do the KMZ. Oh, there you go. Sorry.
Yeah, no,
Now
totally.
it's popping up.
Okay, awesome, awesome. Yeah, I think even if the KMZ file, if you don't open it, all that gives us is all these extra information, like our study area in this yellow box, all these hard hats, which if you click on them, they have like new windows that give you background information. But if you still put in like the coordinates, I think you can still see the study site. But yeah, open the KMZ file and all this extra information should pop up. Okay.
Okay, but the yellow box doesn't show up around my point.
Okay. Can you share your screen?
I'm on the same laptop that doesn't have screen sharing accessibility.
Okay. Okay. Then yeah, and you went under file.
Because all you did was you just put the point in, correct? And it did it itself?
Yeah, you just put in the coordinates and it just takes you to the area.
Yeah, it took me to the area, but it's not coming up with the yellow box.
Yeah, and is the Appalachian Mountain top, is this showing up under your places here?
Yeah.
Is it checked?
Yeah.
Okay. Are any of your layers down here besides borders, labels, places, are these unchecked or?
Let me take off 3D buildings. And then the rest are the same.
Yeah, so borders and labels, places, and the terrain, these options, you can just keep these 3 selected. I think maybe then if they're unselected, maybe that's why it's not showing up, but.
Okay, I can just try to follow along, I guess, if they don't show up.
Yeah, you can follow along. I think I'll be going through most of it like with you guys anyways. So yeah, if not, we can always just try to see after class like what's the issue here. Yeah,
Okay.
yeah. Okay. So okay, well now back to I guess I'll just like there's a chat here too. Did you zoom out once you went into the coordinates? Yeah, just, yeah, maybe zoom out of the coordinates. Maybe that's one, but yeah. Well, if we go back to like getting our polygon area, I'll just, again, just rename it to maybe polygon 1, where, yeah, so I guess to start our polygon, once you click on this add new polygon button and you rename it, your cursor is now this black or this like square where you can just click anywhere on the map and it'll start your polygon for you. And I guess one rule of thumb is for you to just pick a direction and stick with that direction. So either if you want to go clockwise, just make dots going clockwise, or counterclockwise, then just continue going counterclockwise. And I wouldn't be too hung up on whether or not your measurements are the same as other classmates, because how detailed or how accurate your measurements are depends on how closely you follow this yellow polygon for a study area. And so say if I wanted to be a little bit less or more general about this, I can maybe not follow so closely along my polygon, and say I'll just select our sides here like this. But to end our polygon, we would just double click. And if you wanted to move around your points, you can just hover over whichever point you want and then just click and drag your points, and that will adjust your polygon for you. So right now in our window, we have Google Earth Pro. We renamed it. We're under description, but all the way at the end, this last tab is measurements. And it's giving us our area as square miles in units of square miles. But in our Word doc, we want to have our area in kilometers squared. So to change this, we would just click on this, click on our units, and we can go on this drop-down menu to select square kilometers. So for our first polygon, then our area is 50.4 square kilometers. And we can, if we go back to our Word doc, for this very first approximate area of cleared land, we can put 50.4 kilometers squared. So there is area that isn't, like discolored area that's affected by coal mining that isn't considered in this yellow polygon. So there's 3 little areas surrounding, and that's when you're gonna make another polygon, more polygons to look at the area of those lands. So if we go back to Google Earth Pro, from here we can just say, okay, that'll save it. That'll save your polygon. If you want to unselect it, it'll show up on your places and you would just unselect that polygon. And then here, the areas that aren't considered in this main study site, but are affected by coal mining is this area at this top, this big patch of discolored land. Also on the side, there's this area. And in this top left corner, top right corner, we have this small patch of land too. So to get those areas, again, we just do the same process where we would just
Hey, Maggie,
yes.
how do you end your polygon?
Sure. So let me just start my polygon here. I edit as in move points around, or
Like I'm done making the first one and I'm trying to like get those measurements like you had in the kilometers, but I don't know how to do that.
okay, sure. Here, let me just make this polygon for this top corner area. So this small patch of land that's discolored, I would just make my polygon and double click on the last point to end my polygon. And so right now we're in description. If we select measurements, if it's in a different unit, you can just change that unit. And what if it's not in square kilometers, if it changed to another unit, you can just switch it back to square kilometers here. Did that answer your question?
Yeah, it is. Every time I click back into the Google Earth, though, I keep messing up my polygon, so I got to keep starting over.
Oh, okay. Well, once you get your area for that, like for that one polygon, just write it down in your Word doc. And well, you're not turning in the KMZ file like that you're working on right now. So just write down the area here of your polygon and put it in your Word doc. Yeah, even if it doesn't save, at least know that whatever you do on Google Earth Pro, you don't have to turn in. So, right. So for one part of that area, those additional areas, you can put 1.2 square kilometers. And that would be one of the additional areas you can put here. And then you would again do the same process of finding other polygons and doing those 2 extra polygons and filling out these 2, and then add them all together to get the total area impacted. So now if we go back into Google Earth Pro, I will unselect that second polygon and see if we wanted to zoom in actually and look at the area of land that's been affected by coal mining. If we just zoom in really close to this border, we can already see from this overview that the land for coal mining has been relatively flat compared to land that's been untouched. There's steeper slopes on the side. So if we're comparing the 2, we can already see this difference if we move around the edges of our study site. And to get a more, get a horizon view, we can hover over this eye compass at the top and just click on, say, this arrow, our north arrow, and zoom in even more. And we can more clearly see the difference between the area that's been affected by coal mining and the area that hasn't. So pretty different from here. And that's how you can use those different tools to move around your study site. But that's basically it for question 1. It's just making polygons, adding them together, and then describing what you see in the surrounding area. If we move on to question 2, we're looking at Blair Mountain, very historic site where it's a fight between coal companies and the American government over land to mine for coal. And the fight is still going on today, but we can look at that area by copying these coordinates, 37.89 minus 81.84. So we'll just copy those coordinates, go back into Google Earth Pro, and in the search bar in the top left, we'll just paste those coordinates in and we can click search.
Hey, Maggie, I don't mean to be...
Oh.
Go ahead.
Oh, I was just going to ask, do we have to put anything else for question 1?
Besides that polygon, that area that I found with you all, and that one section, that extra polygon that I made, the other 2 areas that you can look at to get those 2 extra additional areas would be, it's on the sides of the polygons that are discolored. So we're looking at the total amount of land that's been affected by coal mining there. And so along with, now that we're going to just zoom back in. So we got our main area of our polygon here. But those other two areas that you can find to make more polygons around is this area and this area.
Okay, thank you.
Yeah, no problem. Did someone else have a question?
Yeah, I'm still trying to figure out how to like close and end the polygon because when I double click on the last point, it doesn't do anything.
Okay. Like you would still you're still moving around and
Like I've finished making the first like the first big polygon, and then when you say to end it, you double click on the green dot. It doesn't do anything for me.
Okay. Here, let me just pull up my second polygon or my first polygon again. So are you saying like these points, like you're still, they're making extra points that you don't want, or like you?
No, so I've done all the points, but I don't get any of the information. Like I mean,
like,
I went over to like measurements now and I see that, but like when I'm done with that, do I just say okay?
Yeah, you just click okay, and that's it.
Okay. All right. Do I need to change the measurements into anything or no?
Just make sure that it's in the units that we want it in. So I think it shows up as miles before square miles, but we just want to keep that or change it to square kilometers.
Okay. All right. Thank you.
Yeah, no problem. Okay. So let me get the coordinates for Blair Mountain and go back into Google Earth Pro, and I'll just paste them into our search bar and it'll take us to that next study site. So again, it's going to, oh, sorry.
One more question. How do you see those numbers again in the polygon after you've created it?
So if you go under your places, if you've saved them right now under polygon 1, you would just click on that. You'll right click, and on this drop down menu, there's all these options. At the bottom, there's get info, and it'll open up that window for you.
Okay.
Yeah. Cool. Right, so this is for Blair Mountain. And again, it's going to zoom us in really close. We can just zoom out to look at our whole study site. And it's the area that we want to make our polygon for this question is basically this land that's been discolored. So we'll just click on our add polygon tool. We'll just rename it to polygon Blair Mountain. And we can just start our points by just clicking on this land area and just moving around. Pick a direction, stick with that direction, and just click to add our points, and then double click to end our polygon. Go back under measurements tab to look at our area. It should stay in units of square kilometers. If it's not in square kilometers, you can change that by selecting this, going into the drop-down menu, and getting back to square kilometers. Right now for this area for Blair Mountain, it's 9.93 square kilometers. You guys can write that into your Word doc. Right now, I'll just click OK. And I will just unselect this because other different additional information that we can find you can read more up on Blair Mountain in this case study by clicking on this flag icon. So Blair Mountain, the fight between labor unions, coal companies, and the American government over this piece of land where through mountaintop removal, when you blow off the tops of mountains, along with coal, other things also fly out like rocks and debris, and along also there's like noise pollution, so it's like noisy and sometimes it can go like over 24 hours a day. So the local residents around this area, they complained, and how the coal company resolved this was just by buying out their properties and making the surrounding communities sign a contract to say that they won't come back, they won't complain about coal mining ever again. And so if we read here, our philosophy is not to impact people. So if there are no people to impact, then that is consistent with our philosophy. And that's how the battle ended today. So Blair Mountain, additional information that you can read up on here to answer that question. If we go back into our Word doc, that's what, there is a chat. How much was it for Blair Mountain? The land area? Yes. Okay, so if we go back under this polygon, Blair Mountain, yeah, 9.93. But
Where did you see that information? That little pop-up tab?
sure. So I'll just unselect this. There's this flag icon.
Okay.
Yeah, and the hard hats too on some of the study sites. You can click on those to get additional information. So that is for question 2. That's how you can answer question 2. For question 3, we're going to go to the isleofmountains.org. So that's the same organization that made that video that we saw on mountaintop removal. And so we can go to this website by just copying this link, going into Google. We can paste it into a new tab. And it should take us to what is mountaintop removal coal mining. But if you're not on this page, you can get to this tab by hovering over learn more. And this very first selection, what is mountaintop removal? If you click on that, it'll take you to this page. So we have some background information on mountaintop removal, the US EPA definition of mountaintop removal in this green box. And the 6 main components of mountaintop removal process is first, clearing out the land, clearing out vegetation for the coal companies and all their equipment to come in. And then the second main component is on blasting. So they find the seams along the mountain where the coal is, and they put explosives around those seams, and then they blast off the tops of mountains. And then, but the thing with that is that along with coal coming out, again, there's other debris, other rocks and things that are flying around, along with noise pollution because it's noisy. The next step is to dig the coal out. Once you blow off the tops or the debris or everything that's holding the coal in, you dig the coal out. And this dumping waste step is, usually done illegally, where they just illegally dump the waste, the byproducts of all of these from the coal mining process that's usually toxic. So they should make like a toxic sludge dam where they dig a hole, they fill it, they line it with concrete, and if they're really good, they line that with plastic, and then they put all that toxic sludge in, and then they dam it with, and they just leave it like that, and they say that they, covered and they took care of the waste. But the thing is with toxic sludge is that it still has a liquid consistency. So if there are any cracks in your ditch, in your hole, if there are any earthquakes, and if that liquid sludge, if the dam breaks, if it goes into the surrounding area, it's toxic. So if it goes into your groundwater, all of that a lot of implications for people living in the area. But usually this is the step that they do need to do. Afterwards, you process the coal for it to be used. And at the end, the reclamation or the restoration step, it's required by the federal government for coal companies to restore the area that they mined coal from. But usually, at most, they would just spray seedlings of one type of plant and they would just call it a day. But to properly restore an area takes a lot of money, especially after you have all your heavy equipment that tracks along the soil and just compacts your area. You also need to, besides putting in just one type of plant, you need multiple vegetations, different types of vegetation for your area to increase like biodiversity and things like that. So all of this takes a lot more money, but the reclamation step is required by the federal government. It could improve from how coal companies are doing it now. So if we scroll down, this is information that's on your Word doc that we covered already. So what is the mountaintop removal mining? Where is it happening? Again, it's like in Kentucky, West Virginia, and a little bit of Tennessee. And if we keep on scrolling down, these are the 3 environmental effects that you can talk about in your Word doc. So one of them is flooding. When you do mountaintop removal and you blow off the debris and all these particles from mountains, they settle into areas and valleys where those particles weren't before. And it changes waterways, it changes the flow of your streams. And so flooding is a very common effect that we see from mountaintop removal as the landscapes are changed. Blasting is the second one. So along with noise pollution, when it's like pretty noisy, these blastings can go around 24 hours a day. And along with coal that's being blasted out, there's other particles like boulders, soil, things like that that's flying around. And they, it can also cause cracks in the foundations of your homes, in your, all of that. So blasting has a big effect on people living nearby. And then of course we have our sludge dams. Our sludge dams, which, is holding in all your toxic sludge at the end of your coal mining process. And the biggest sludge dam, or one of the sludge dam breach was covered in that video in Martin County in 2000, which sent more than 300 million gallons of toxic coal sludge into the tributaries of the Big Sandy, causing what the EPA called the biggest environmental disaster ever east of the Mississippi. So these are the 3 effects that you can talk about for that question in your Word doc. For question 3, now if we wanted to look at the like a sludge dam, one of them can be found in Glen Alum Mountain at the coordinates of 37.62, negative 81.94. So we can copy those coordinates. You can go back into Google Earth Pro and paste them into our search bar in the top and just click search. Again, it'll zoom us in really close, but we'll just zoom out. And the sludge dam is actually a little bit to the right, and it's this area here. So this is our dam. This is the sludge that the dam is holding in. We can see that there is this terracing. Terracing is usually what happens when you're moving construction materials, when you're moving heavy equipment, things like that. And terracing, that just creates these lines where your soil is really compact now and from all these moving of heavy equipment. So terracing is another effect too. But to get this slant area, again, we're just gonna be making another polygon. So we'll go under our Add Polygon tool, and we'll just name it to Polygon Sludge Dam. And we can click on the area that we want and just move around this sludge dam, click around and select these points around this area to get the amount of land affected by this sludge dam. We'll just double click to end our polygon. And again, we can go under the measurements tab. And it should stay in square kilometers, but if it's not, again, you can change that back to square kilometers. And thus, the land affected by this sludge dam, or the amount of land that the sludge dam takes up, is 1.51 square kilometers. 1.51 square kilometers. We can click OK to save our point. And in our Word document, that's what we can put here, 1.51. So now for question 5, the total area disturbed by mountaintop removal. We're going to compare, let me just read you this question. According to the I Love Mountain organizations, there are over 501 mountains that have been impacted by mountaintop removal mining, and a total area of more than 4,694 kilometers squared has been disturbed. So how does this land compare? How does this area compare to the total land area of A, New York City, which is 831 kilometers squared, and to the city of San Francisco, which is 122 kilometers squared? So in other words, how many times larger are these areas compared to the two cities? So the amount of land affected by mountaintop removal is 4,694 kilometers squared. How many New York cities can we fit into this land area? And how many San Francisco cities can we fit here? So you're just dividing these two numbers. So you're dividing 4,694 kilometers squared by 831 for part A. And you're dividing that same number, the 4,000 number, by 122 kilometers squared for part B. So at the end of this, you should get two numbers. So one for part A and one for part B. And show your work down here too, under part 5 or under question 5. But that is question 5. If we keep on scrolling down, or well, did anybody have any questions so far about how to answer question 5 or any of these other questions before? Okay, so for question 6, we're now looking at wind energy and solar farms, how much land these take up. So there are 3 farms that we're looking at, or that's given to us, is Nevada Solar 1, Palm Springs Wind Farms, and the Altamont Pass Wind Farms. You can ignore C, the Altamont Pass Wind Farms, because we are only looking at one solar farm. So to be more equal about that, we'll also just look at one other wind farm. So instead of looking at 2, we'll compare the one solar farm to the wind farm. But the solar farm that we're looking at is in Nevada, in this desert area. The coordinates for that is 35.785 and minus 114.9944. We'll just copy those coordinates, go back into Google Earth Pro, and then go look at that land area in Nevada. There is a chat. Okay, awesome. We'll just paste those coordinates in and click search. It'll zoom us in really close again to our solar farms. If we zoom back out, we can see this main area, which has our main solar PV farm. But if we zoom out a little bit more and just click and drag up, we can see that there's more solar panels up here too. So this is another area, and there's even more solar panels up here. So these are the 3 areas that you can make your polygons on to get your main or your total land area affected. One thing about solar farms is that, yes, solar panels or solar power, it's renewable, and it's great that once you mine for the materials once, you don't really have to maintain them or put too much money to get like energy outputs from them. But even though these solar farms are in the middle of the desert in Nevada, it does affect the desert ecology wherever you put your panels on. And once you put these solar panels down, you can't really do anything else with this land. You can't put buildings on top of them. You can't have cattle around them. You can't really grow crops or anything in this area because it's taken up by these solar panels. And because solar panels are really reflective, they're reflective, so it gets hot, even hotter than how it normally would be. So not a lot of things can grow in between these solar panels, but that's one of the other sides of renewable energy for solar panels, that is. And we can just make our polygon for this area by, again, going back to our Add Polygon tool.
I have a question, Maggie.
Yes.
So you're going to be doing 3 of them to get the total amount of, okay.
Yeah. I'll do this first one with you all, and then the other 2 you can do on your own, and just add them all together. Yeah. So for this first one, I think that's one nice thing with solar farms is that you can be, you can just follow the edges of your solar panels and get a little bit more exact of how much land is being taken up by them. We'll move these points around, make sure it covers the solar panels that we see. And then again, under our window, we can click on measurements, and it should stay in square kilometers. And the area for this main polygon is 10.9 square kilometers. And we can just save that if you want, click OK. And then once you're done, yeah, get the other 2 areas up here of these solar panels. How much land do these 2 farms take up? And then add them together to get your total amount of land area affected. So now if we go back to your Word doc, that's what you can do for part A. For part B, we're now going to look at a wind farm in Palm Springs. And the coordinates for that is 33.91, negative 116.62. So we can just copy those coordinates, go back under Google Earth Pro, and in the search bar in the top, we'll just paste those coordinates in, click search, and it'll take us to our next study site. So when you zoom in really close to the site, these lines, these black lines that we see, they're actually the shadows of the wind turbines. So the actual wind turbines are these white little dots here, because we're looking at it from an overview. We're looking at it from like a map view. So if we zoom out, you can see that they're spaced pretty evenly, and there's a lot of land available in between these wind turbines. And so compared to solar farms, solar PV, you can grow things in between. You can have other buildings in between these wind turbines, and you can also raise cattle here. So that's one nice thing about it. And say if you're a farmer and you haven't really used your land, you can't use it for some other reason, like maybe it's not really fit to grow cattle or farm on it or anything like that. What wind turbine companies can do, they can just rent out just one square piece of land to put only their solar, or to put only their wind turbines on. And that's how you can still get money and income from a piece of land that you couldn't really use before. But yeah, but it's still generating some income because they're renting out that land here. So if we have an overview look of this area, we see that there's wind turbines all along here. And if we move our map up, there's more wind turbines up here. They're all evenly spaced out, but there is a lot of them in this area. So to make it easier for us, instead of getting one land area, and just doing it for every single wind turbine, we're just going to make one big polygon for this whole area. But we're going to keep in mind that there's a lot of it is empty space because the wind turbines don't take up a lot of that space. But to make it easier on us, we're just going to make one big polygon for this area. So we can do that by, again, clicking on this Add Polygon tool. We'll rename it to Polygon Palm Springs. And then we can start our polygon by clicking and going around this land area here.
Is it just that land area?
Yeah, we're just looking at this one part here. We don't have to look at I was just showing like all the other wind turbines on the side, but you don't really have to get that. We're also keeping in mind that there's we're also keeping in mind that there's like a lot of other wind turbines around, but there's also a lot of this empty space in between. So we're just making one polygon to make it easier on us. But yeah, I guess let me do that again because I accidentally added all those points, but you can just be more general about this one and say our measurements for this is 7.24 square kilometers. You can click OK, and that's basically the part for Palm Springs. We go back to our Word doc. You can just type in that 7.24 kilometers squared here. We're ignoring the Altamont Pass wind farms for part C, but after that, that is all of the polygons you'll have to make. And for question 7, you're now all of the land areas that you found, you're putting in those numbers here. We're ignoring Altamont Pass down here so we can compare one wind farm to one solar farm. And then you're just putting in all these numbers and ranking them based off of the ecological impact, where from 1 to 3, where 1 is high impact and 3 is low impact. So impact can include whether it's, is there any byproducts from this process that's taking up a lot of land? Can you farm on this land? Can you also do other things? Does it just take up a lot of energy, or does it take up a lot of area that's unusable to us now? And low impact would be like, it doesn't take up a lot of space and all of that. You can explain your answers in more detail in question 8, where you're gonna write 3 sentences comparing the 3 different energy types. So coal, solar, and wind, and you would just type that in down here. But that is basically what you can do for these last 2 questions. Did anybody have any questions about that? Right, so this Word doc is due on Friday midnight. I'm pretty sure you guys can finish this before lab ends today. Lab is supposed to go up to 11:20, but usually we end a lot earlier. I will stay as long as people are around to answer any questions about how to use Google Earth or how to answer any of these other questions like doing calculations and stuff. But you don't have to turn in the KMZ file. You're just turning in your responses to this Word doc. And yeah, so you are, any questions that you have on your grades, any assignments, things like that, just reach out to me about. We can talk about that. But that's basically it for Lab 11. Yeah, there is an end of course survey, always optional, always anonymous. You can answer it if you want to. And yeah, I read through the comments. This is my last semester teaching this lab, so I'm always looking for ways to improve. Yeah, what else? I think you're all doing really well. I'm not like super worried about any of you guys. You can always reach out to me if you have any questions about grad school or things like that. But thank you for this semester. Good luck with finals. And yeah, thank you.
Thank you so much.
Yeah, thank you.
Thank you. Thank you.
Thank you.
You.
Thank you.
Are you ending the Zoom right now, or are you just staying on if we need any additional help?
I'm just staying on if you need any help. Yeah.
Okay, I'm gonna stay until I get everything finished here.